Just a note before the video starts, you're probably going to want to watch the video in the top right corner, the title card, because that gives you all the information you need to know to interpret this video. Hey, so last video I said that I was going to sort of document my thinking, and yeah, I didn't actually end up doing any of that. So this one's different and got a problem. See this from this 16 bytes of RAM. This is great, but it's freaking ginormous. And I realized that I don't actually need all of these components from the registers in this system because I have things like locking the inputs and locking the outputs until I toggle the read and write functions. So I can get rid of like half of this stuff. So what I'm doing here is trying to design a register in a way that's more compatible with this type of grid system. Okay, so I've kind of started the process into designing a different register, and I was able to figure out that my old register consisted of really two sort of registers. There was this register, and then this register, which is the same as this one, and there's this row of comparators in the middle that would stop the signal from going from the first one to the second one. And I would need this as like, I guess, overflow control or something, because I was worried that signals would be coming in, like flicking on and off and stuff. And then if we ended up with a signal that, say, didn't include this bit, if it had been turned on, then the register would load that as on. So I had this one where I wouldn't let the signals go to the second one until this one was reset. And if it's reset with signals still going into it, it will still output that same signal. See, this torch here is still on after that reset. So then that sends it to the second register, who only gets the information that you save when you reset the first register. But since on our RAM, we don't actually have signals going into the registers unless we specifically choose them, and the signals aren't like fluctuating until we tell them. I mean, the signals aren't fluctuating before we say save this. So I was able to get rid of that whole first part, and this is just the second part, so I was able to shorten it down a lot. And the little problem I had was I carry the signals up to here to be inputted in, and I thought that since the block output signal in this purple right here, I need a repeater here anyways to block the signal from the torch to the redstone. I thought I'd be smart and use that to signal up to the next register, but that only works here. I don't have enough space to block the input register, and it's just a whole mess. So I have actually made some progress here. We've got one single slice of the system, but there are 4 registers in here. So each of these will be part of a row. But just to test, we have a slice here. And the way it works is instead of having 2 registers like that one, we'll just have the one where this signal from the lower yellow line will only go and get saved in these green blocks when we open up the right signal. So orange here represents the little areas where the right signal needs to go. And then purple here is where all of the read signals will go. So when we have the grid of the red and blue wires, then that will all connect to these orange and purple nodes. I'm just going to get to it. I'm going to build an entirely new 16 byte array using this design. you enjoyed that time lapse. That was my first time doing something like that. Just a bit of an experiment. But so here we have it. It is much smaller than this monstrosity over there. It's much more compact and it's prettier too. You can see just like the last one, we've got the input row and then the output row, the multiplexer right here, as well as the read and write bars. If you don't know how any of this works, I'd recommend checking out my part one video where I built that because I go into detail about how this grid is laid out and what all of these gates actually do. So right now I just have the registers storing the number corresponding to whatever actual like register they're in. So this is register 0110. So we should get 0110. Yeah. To see more about this, check out my last video. This has been TIO7, and goodbye.